Good evening, all. Roshit sir, good evening.
Good evening, Sushmita.
Yeah, you can start the session, sir.
Okay. Yeah. Students, can you ask your friends to join fast while I start my whiteboard, please? So very good evening, students. Am I audible?
Yes, sir, you are audible.
Let me share my screen. Yeah, good evening, Kajal. Good evening, Sai. Good evening, Shubham. Good evening, Suyash. Good evening, Jinath. How are you all doing? Is the assignment done? Yes. Is the assignment done? Okay, Harsh has done the assignment. Good. Anyone done the assignment still? Yes, no. Yes, Kajal. Good. Okay. Anyone facing any issues in the Kicksort implementation? Anyone facing any issues in the Kicksort implementation? Good evening, Vaishnavi. So what we have discussed in the last class, uh, we are done with selection sort, and then we have implemented this code as well using selection sort, and then we went with the kicksort, right? So in the kicksort, we discussed the algorithm, right? We discussed the algorithm along with pseudocode as well, along with pseudocode as well, right? So how does kicksort algorithm works? How does kicksort algorithm works? Yes. So if I take, I will quickly recap the kicksort algorithm. Uh, if I take an element, something like 8, 6, okay, then 15, then 19, then some 7, then some 5. Okay. So here, how does this algorithm works? Basically, I will be taking a pivot element. Okay, I will be taking one pivot element at any position. At any position, you can take out the pivot element at the first position or at the last position or in the middle position. You can take the pivot element, but during your like Kicksort, we also discussed about recursion yesterday, right? So what is recursion? What is recursion? What is a recursive call? So basically a function calling itself means the method it will be calling itself, like we have seen yesterday factorial. So inside the factorial, we will be again calling the factorial, right? We'll be again calling this factorial. But to stop these recursive calls, what we need to do, we need to have a base condition set, right? Some base conditions should be set to stop these recursive calls, stop these multiple recursive calls. If the multiple recursive calls were there, it will result in stack overflow, right? We have also seen that website yesterday, stack overflow. Okay. So basically what will happen, every recursive call will be inside a stack, right? So the first recursive call is nothing but your main, right? And the first function call or method call is nothing but your main, and then factorial of 5 will be called, then factorial of 4 will be called, right? Factorial of 3 will be called until 1 it will go on calling, right? Until 1 it will go on calling. And when it is 1, what will happen? We are returning. We are returning, in the sense we are stopping this function call and returning the 1 to the previous one, that is factorial of 2, right? So here 2 into factorial of 2 will be there. That will be returned to the, like, here 3 into factorial of 2 will be there, right? 3 into 2, or 2 into 2, right? 2 into 2. And this 2 will be returned to the 3 into factorial of 3. Like this, it will return and it will result to the main method. Okay, from which method the return call is done, from which method the first return call will be done, to that method the output you will be getting, right? So this is how the recursive call will happen, right? So the recursive calls, the recursion is implemented in kicksort also and in merge sort also, right? So basically these both algorithms were part of divide and conquer. Okay, divide and conquer. So we will follow the during division we'll follow the your we'll follow your recursive calls. Okay, we'll follow your recursion. Okay, so for that reason I have explained the recursion also yesterday, right? So that is how we discussed yesterday. Why? Okay, that is how we discussed yesterday. So coming back to your kicksort. So how does kicksort works? Basically, we need to take first the pivot element. Either it can be first, either it can be last, or either it can be in the middle. Okay. For now, I am taking the last element as a pivot. Okay. Let me put 5 as a pivot. Okay. Yesterday I put the first element as a pivot, right? Now I am taking the 5 as a pivot. Okay. So now, so 0, 1, 2, 3, 4, 5. Okay. So we will be taking 2 pointers. For every iteration, we'll be taking 2 pointers. That is, you can take it as start pointer. You can take it as end pointer. Okay. When start, there are 3 conditions we are checking, right? When start is less than or equal to pivot, then what we need to do? Students, can you tell me what you need to do in this case when start is less than or equal to pivot? Start plus plus, you will increment the start pointer, right? If start is less than or equal to pivot. Okay. If end greater than pivot, if end greater than pivot, then what you will do? You will decrement the end pointer. You will decrement the end pointer. But when this is how you will do, and when this both are stopped, means if start is less than end, start is less than end, means these both have stopped, means the start has got greater than pivot element, or this end has got lesser than or equal to pivot element. Then in that case, what will happen? You will swap the start and end pointer, right? Start comma end. Yes or no? Yes. Okay. And then if suppose end has crossed, means if end is greater than end, like if end is lesser than start, or start is greater than end, means start has passed the end pointer. Okay, it has crossed the end pointer. In that case, what you will be doing? You will swap pivot element with the end element, so this is how you will be doing, right? Yes. So when start is less than end itself, you will run these both conditions. If start is less than end only, you will run these both conditions. Once the start is greater than end, then you will just swap the pivot and end. So for every partition, what will happen? For each and every partition and rug. So for each and every partition, for each and every partition, you will get pivot element at the correct position. Pivot element at the correct position. Okay. So means what will happen? This 5 will be in the correct position, and before this, all the elements will be lower, and after this, like or lesser than your pivot. After this, it will be greater. Okay, after this, it will be greater. Okay. So basically, if start is less than end only, we will perform these operations, right? If start is less than end only, we'll perform these operations, right? Otherwise, what we will do? If we'll write inside a while loop, right? While start lesser than or equal to end. While start lesser than or equal to end only, what you will do? You will perform these two operations, right? And then again you will check if start as stopped or end as stopped. Then you will swap the start and end, and then again you will perform the operation. Then again you do this operation always until start is lesser than or equal to end. If it has crossed when start is greater than end, then what you are doing, you are swapping the pivot element and the end element. Are you clear, Anurag? Okay, so now now the pivot we have taken as 5. Okay, the pivot we have taken as 5. Now let me know. So let me know now if so first what will be compared? Okay, first what will be compared? Like start is lesser than end only. It will go inside. It will go inside the while loop. It will come here. Start is lesser than or equal to pivot. Start is lesser than or equal to pivot. 8 is lesser than or greater than pivot. Condition is true or false? 8 is lesser than or equal to 5. Condition is true or false? It is false, right? 8 is lesser than 5. 5. No, it is false. So start will be here itself. Okay, start will be here itself. Then 5. 5 lesser than or equal to 5. Condition is 5 greater than 5. Like 5 greater than 5. This one, this condition, right? End is greater than pivot. 5 is greater than 5. Condition is false. So what will happen? End will be staying here itself. So now start is less than end will be staying here, start will be staying here. We need to do swap. Okay. So 5 will be coming here, 6 will be coming here, 15 will be coming here, 19 will be coming here, 7 will be coming here, 8 will be coming here. Okay. We are doing a swapping of start and end. Okay. Then again, start is at here, end is at here. Okay. Now again checking. 5 is lesser than or equal to 5. Condition is true. Condition is true. Right? So now what will happen? This will be moving here. 6 is lesser than or equal to 5. Condition is false. Right? Condition is false. So start will be here itself. And then 8 greater than 5. Condition is true or false? Condition is true. Right? We'll be moving the end pointer. 7 is greater than 5. Condition is true. We'll again move the end pointer. 19 is greater than 5. Condition is true. So again we'll move the end pointer. 15 is greater than 5. Condition is 15 is greater than 5. Condition is true. We will again move the start end pointer. Now 6 is greater than 5. 6 is greater than 5. Condition is true. We'll again move the end pointer. End will be here. Okay. Now you see start as crossed, like means start as crossed the end pointer. End is at here, start is at here. Which steps should Sirisha? Like 15 or 6? Can you point out the number? At which step? 7. Okay, let me again do. Okay, so end is a tier, right? End is a tier. Our pivot element is phi itself. Are we clear until this point? Our pivot element is phi itself. So into pointer, what we need to check basically, we need to check if end is greater than pivot. Okay, if end is greater than pivot. So are you observing my board, Anurag? What is there here? Start is lesser than or equal to pivot. End is greater than pivot. Here we are doing end minus minus. Here we are doing start plus plus. These two conditions only you take care now. Like I will explain from initially again. This is the second time I was explaining. Okay. Like yesterday in the end, I have explained, like in the session, I have explained, and then I was explaining, I explained right now, and then I will explain again while writing the code. Okay. I can't explain again, but I will explain while writing the code again. Okay. I will try run the code again. Okay. So here end is a tier. Okay. End is a tier. So basically, what we need to check? Start lesser than or equal to pivot, end greater than pivot. If start is lesser than or equal to pivot, we need to increment the start pointer. Okay, if end is greater than pivot, we need to decrement the end pointer. Okay, these two conditions only you keep it in mind. Okay, now start is a tier. If you think I will again explain this iteration. What I will do, I will take another color. How should I take it? Mhm. Okay. Yeah. So now start is a tier. Observe my red pointer. Okay. Observe my red pointer. Okay. My pivot element is 5. Okay. My pivot element is 5. Now tell me start 5. 5 is lesser than or equal to 5. Start is lesser than or equal to pi. 5 volt. Yes. So what will happen? We need to increment the start pointer. Okay. We need to increment the start pointer. So yes, 5 is double equal to 5, right? So then we need to increment the start pointer. Now start is a tier. Okay. Start is a tier. Okay. So now 6 is lesser than or equal to 5 or greater than 5. 6 is less than or equal to 5. Condition is true or false? Condition is false. So what will happen now? S will be at here itself. It will come out of the loop and it will go and execute the next condition. Okay. It will come out of the loop. It will go and execute the next condition. So start is at now here. Okay. Now going to the end. End is greater than pivot. So 8 is greater than 5. Condition is true, false. True, right? So I am removing the end from here. I will write the end here. 7 is greater than 5. Condition is true, false. True. What I need to do? I will remove it from here. I need to decrement the end pointer again. Okay. 19 greater than 5. Condition is true, false. Condition is true. Again, I will decrement the end pointer from here. 15 greater than 5. Condition is true, false. Condition is true. So again I will decrement the end pointer. 6 greater than 5. Condition is true or false? Condition is true. Again I will decrement the end pointer. Now it will come here. Okay. Now it will come here. Okay. So 5 less than 5. 5 less than 5. Condition is 5 greater than 5. Condition is true, false. 5 greater than 5. Condition is false. Okay. So E will be like end pointer will be here, start pointer will be here. Are we clear until this point? Sirisha, Anurag and everyone? Okay. Now you see, now next condition is what? Next condition is after this condition. What is the next condition? This is the next condition, right? If start less than end, condition is false or like false or true. End is at 0, start is at 1. 1 less than 0. Condition is false. It will not go inside. Okay. So now it will come out of the loop. Like it will go to the while loop again. At the while loop, what we have written, start less than or equal to end. Start lesser than or equal to end. Is condition is true or false? Condition is false. It will come out of the while loop, and then what will happen? It outside the while loop. Outside the while loop, this is there. Okay. Outside the while loop, this is there. If start greater than end, what I should do? I should swap pivot with the end. Pivot is what? Phi itself, right? Pivot is phi itself. End is also phi itself. So swapping will not be required. Okay, swapping will not be required. Are we clear? Are we clear? This is your first partition. Okay, this is your first iteration. Basically, first recursive call. So what is happening here? If you observe now, pivot is at this position. All the elements right to the pivot are greater than the pivot element. See, 6, 15, 19, 7 and 8 are greater than the pivot. Okay. Yes. Now what you need to do? So pivot -1 to before elements, you need to do another partition. But since there are no elements here, I should be doing pivot +1 to end. Okay. Pivot +1 to end. This is one partition, right? This is one partition. I should be taking another partition. Now what is the pivot element again? So this is at correct position. We will leave that element and then we will again do the partitions from here. We will do again the divide from here. Okay. Now again, what is our pivot element? Pivot element we have taken in the initial array at the last itself, right? So here also you should take it at the last itself. So what will be happening now? The pivot will be changed to 8 itself. Okay, pivot will be changed to 8 itself. Okay. Now again same. Now start will be at here. Okay. This is the second partition. Okay. This is a second partition. So now start will be at here. End will be at here. Fast you tell me. 6 lesser than or equal to 8. Condition is true, false. Condition is true, right? We will move the start pointer. 15 lesser than or equal to 8. Condition is true, false. Condition is false, right? So start will be here itself. Okay, start will be here itself. Then coming to end. 8 greater than 8. Condition is true, false. Condition is false, right? So end will be at here itself. Okay, end will be at here itself. So now what will happen? Like 8 will be 8 and 15. We need to swap this condition, right? This condition. 8 and if start less than end, swap of start comma end. So 8 will be coming here. Okay, 8 will be coming here. Eight will be coming here. And what is the next element? This is 15, right? 15 or 19? No, 15, right? Yes. So it will be 15. Okay. So 8 and 15 were swapped now. Now let's continue the iteration. Let's continue the iteration. Now 8 is lesser than or equal to 8. Condition is true, false. Condition is true. So it will move here. 19 is lesser than or equal to 8. Condition is true, false. So it is false. So S will be here. 15 lesser than or equal to 8. Condition is true, false. 15 greater than 8. Condition is true, false. 15 greater than 8. Condition is true, false. Condition is true, right? Condition is true. So it will move here. 7 greater than 8. Condition is true, false. Condition is false, right? So start will be here. So now what will happen? 7 will be coming there. Start is lesser than end. So 7 will be coming here. 19 will be moving here. Okay. Now start is at this position, end is at this position. Okay. 7 lesser than or equal to 8. Again starting the iteration. Since start is lesser than end, it will again start the iteration. Okay. So 7 lesser than or equal to 8. Condition is true, right? So start will be coming here. 19 is greater, 19 is lesser than or equal to 8. Condition is false. So start will be here. Okay. Start will be here. Then 19 is greater than 8. Condition is true, right? It will move here. Okay. 7 greater than 8. Condition is false, right? So when condition is false, it will move out of the loop since start is lesser than end. Okay. Since start has already crossed the end. Now what will happen? At seventh position, what we are writing? We are writing the, at this position, we'll swap the pivot element. Okay. We'll swap the pivot element. Okay. So basically what we will be swapping, we'll swap it here 8 and this is 8. Okay. And this is 7. This is 8. Okay. So if you observe now, 6 and 7 are lesser than 8, lesser than pivot. And if you see, it's like 5, 6, 7 are lesser than pivot, and 8 after this they are greater than. Only this part you need to swap again. And this is again you will do the swap, you will do the division. Here also you will do the division. Okay. Like this, the algorithm works, and the code, like this is how the pseudocode works. Okay. So let me go to my Eclipse. Okay. I'm writing my main method. Okay, I'm taking some elements, the same elements I will be taking. What are the elements? 8, 6, 15, 19, 7, 5. Okay. 8, 6, 15, 19, 7, and then 5. Okay. And then I will print the elements as well. Enter D array. Okay. Entity sys out. Okay, I'm printing the D. Okay. Then I will be first writing the partition logic. Okay. So static int partition. Okay, static int partition, and then we will get our array. Okay, int array, and then we will be getting our lower bound value. Okay, we will be getting the upper bound value. Basically, like you can take it as lower bound or upper bound or nothing but your start and end pointers. You can take it as start and end only. Into start, into end. Okay, so this is your partition logic. Partition logic, what you will be writing basically. So you will be passing at the end, you should pass just the end value you should be passing for the partition, right? So let me write the partition logic. So pivot element you will be taking int pivot element is equal to array of you can take it as start itself. Okay, let me take the first element itself as a pivot element. Okay, this element only I'm taking as a pivot element. Okay, and then what I need to do, I should be writing the condition, right? While start lesser than or equal to end. While start lesser than or equal to end. Then what you should be checking, if array of start lesser than or equal to pivot, right? If array of start lesser than or equal to pivot, what you need to do, if it is lesser than or equal to pivot, what you need to do, you should increment the start pointer. Okay, if start is lesser than or equal to pivot, then increment the start pointer. If array of end greater than or equal to pivot, right? Greater than pivot, then what you need to do, end minus minus. Okay, then if start is lesser than end, if start is lesser than end, you will be swapping of the array of start. Okay, array of start comma array of end. Okay, this swap function also I'll be writing it up, but okay, then what you'll be doing, once this operation is done, in the sense your end has crossed with the start, or not, your start has crossed with the end. So in that case, what I need to do, if start is greater than end, if start greater than end, what you'll be doing, so basically you need to, like, no need of checking also, because anyways while this loop is not executing, it will be greater than end itself. Directly you can swap the array of start, but before that you can check one other condition also. If start, otherwise you can directly swap it up, not an issue. Okay, if swap array of start array of end comma array comma pivot. Okay, you will be swapping this up, and then you will return your end. Okay, you will return your end. So let me write this function as well. Create method. Okay, swap of int I comma pivot. So basically int a comma int b. Okay, so what you will be writing in this, you will write your swap. Okay, you will write your swap. And comma pivot. What I'm doing. Just I will pass end comma pivot end positions and then pivot position. Okay, end comma pivot end comma pivot. You can take it as array of start only and then pivot position I cannot pass pivot position. Then take it as start itself. Okay, then you can change it to array of pivot list. Okay, array of okay, so then what you're doing, then you can just pass these elements from here. End comma pivot, you're passing just that's it. Okay, right. So end comma pivot, you will be passing it up. End comma pivot. Okay, this is your end. This is your pivot. This is your A, this is your B. You can take it as A comma B. Okay, basically you will pass the positions of your swap. Okay, then what you will be doing, you can take and array also you should be passing. Okay, array also you should be passing. Along with this, you'll be passing the array as well. Along with this, what you can do, you can pass just the start comma and okay. So here I'll be taking the array as well. Okay, into A comma B. Like physical, I'll take it as first and then second. So what we are doing here, just doing the swapping in temp is equal to array of first. Okay. Array of first is equal to array of first is equal to array of second. Okay, array of second is equal to 10. Okay, just you're doing the swapping of that. Are we clear until this point? Yes, everyone? Clear with this logic of partition? And then I'm swapping those things. Okay, I'm swapping from here by writing a separate function. Okay, now we are going to write a kicksort logic as well. Like for this is the partition logic, whereas your kicksort logic, you need to call recursively, right? Those functions once the pivot element, once the end position is done, once you have swapped and everything is done, then you will be returning the end position, and then what you will do, you will partition that, right? From pivot minus one, like basically 0 to pivot minus 1 and pivot plus 1 to end pointer, right? So I'll be writing a logic of I'll be writing a logic of kicksort as well. Okay. So static void kicksort. Okay, I will take it as kick only. That's fine for me. Okay. So I'll be taking an array int the same array again. Okay. Then I will take the pointer, that is some lower bound pointer I'll be taking. And then I'll be taking the upper bound pointer as well. So basically end of your array. So index of your the first array in the end point of your array n basically. Okay. Okay, then what I should be doing? I should be checking if there are two elements are there or not. I should be checking if less lower bound less than upper bound means lower bound will be 0, upper bound will be 0, 1, 2, 3, 4, 5. Okay, if 0 less than 5. Basically, if suppose there are only two elements are there is only one element are there, then what will happen? The lower bound will also be 0 itself, upper bound will be n minus 1, right? Upper bound will be n minus 1. In this case, it will be 0 itself, n minus 1, 1 minus 1, which is nothing but 0 itself. So it is having only one element. So in this case, quicksort is not possible. You should have at least two elements, right? So for that reason, what you are doing in the array, so you are checking whether if there are two elements are there or not. If two elements are there only, you are starting the quicksort. Okay. So here what you are doing, if for you will be you need to find out first the partition, right? You need to first where the pivot element should be placed, where the end pointer is there. That pivot element, what that position you want, right? That index you want, where the pivot element should be placed, right? So for that reason, you will be like, let me take it as pivot index. You'll be getting that from you'll call the partition first. Okay. You'll call the partition first. You'll be passing the array. Okay. You'll be passing the array and your lower bound, then upper bound. Okay. Lower bound and then your upper bound. And then you will recursively call the function. You will be recursively partition it. How you will be partitioning it? So array comma, you'll be partitioning from lower bound to pivot index, right? Pivot index minus 1. Okay. And then you will be partitioning array comma pivot index plus 1 to upper bound. Okay. You'll be partitioning like this. Okay. You'll be partitioning like this. And then I will call it from here. Quick. I'll call that function quick. And then I will pass my array comma 0 comma array dot length minus 1. Okay. Now you are printing that array as well. Okay. Is this clear? There are two elements. I'm calling out the partition. I'm finding out the pivot index. Okay. Then after I am doing so what will happen now? I will find out the pivot index and then I will quick from array to LB to pivot index minus 1. Okay. I will divide that array. It will go back again. It will go back here. Now lower bound will be your lower bound will be 0 itself, whereas upper bound will be now pivot index minus 1. Means what will happen here? Pivot index minus 1 means nothing but pivot index minus 1. Nothing is there here. So basically, if suppose we are starting the array from 8, right? So 8 before what elements are there? Like 6, 7, 5. These elements will be another partition, right? Another recursive call. For this recursive call only we are doing this. And then after we'll find out the partition and then again we'll come back. We'll do the left things. Okay. We'll do the left partitions and we'll find out we'll do the multiple recursive calls for the left one, and then we will find out the sorted array here. Okay, we'll find out the sorted area, and again we'll come back and we will start with the next array. We'll start with the next recursive call for the right side. Pivot index plus 1 to upper bound. Okay, pivot index plus 1 to upper bound. So this is how it will work. Let me run this. So let me. See, it has been sorted. 5, 6, 7, 8, 59, 19. Okay, 5, 6, 7, 8, 59, 19. So the initial array is 8, 6, 15, 19, and 7 and 5. Now it has been sorted to 5, 6, 7, 8, 59, 19. Return end, like I should be return, like where, why end you're asking again. See, pivot will be at end only, right? Pivot will be at end only, right? See, at this point, you are like, this is your pivot element, right? This is your pivot element. Okay. So what you are doing, you are taking out the pivot element and you're putting at the first position, right? At this position, you have kept it. Now you need to return this index, right? You need to return this index. So only you can divide this left off and you can work on the right off. That index you want it, right? Way to divide. So for that reason, you're returning the end index because this is your end pointer at that time. At this time, this is your end pointer. So you are returning the end index. Clear, Anurag? Okay. So take out this code, execute it. Once after this, I will continue with merge sort.
It's 8 o'clock.
This swap thing, anyways, you know it. I will keep it up in the end. Okay, just observe the. Did I mess up? Okay, just observe both the things once. Observe both the things and execute it also. Let me know if you have still any doubts. Okay, just execute this. And let me know if you have any doubts. Just execute this, okay? Index out of bounds, you should be providing like this, array dot length minus 1. Okay, the upper bound should be array dot length minus 1. 0 to array dot length minus 1, and observe these as well. Pivot index plus 1 and pivot index minus 1. And also see your swapping. Okay, swapping also will be the same, but the thing is you should pass array dot length minus 1. 0 to array dot length minus 1, and then here while start less than end. Okay. Okay, is it done, Mangesh and Anurag? Index out of bounds error is resolved. So Yash, are you done with your this execution? Yes. Time limit exceeded in online compiler. I don't think so. It will exceed the time limit. I think their partitions. Yeah. So this will execute fine. Like execute it inside your IDE itself. That is not an issue. Okay. Like they may have for this large data set, right? They may have the stack field or something. Restriction will be there in online compiler. So you may face issues there. But it was executing fine for me. See, I was able to find the code is fine. Can you share, Mangesh? Can you share your code, your error over the chat box? I can see in which line it was showing error index out of bounds. Yeah, I will be sharing this code. Okay, I've shared it the code in the over the chat box. Okay. 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 Good. Hmm. Mangesh, is a error resolved or? Okay. 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 Let's continue. Let's continue with merge sort. So merge sort, in the case of a kick sort, we will take the pivot element and accordingly we will be dividing it, right? In the case of your merge sort, we will divide the elements. Okay, we will like basically we'll divide all the sublist. We'll divide an array, we'll divide an inputs into multiple sublists, multiple sub arrays, and then we will start the merging until one they will merge it up. Okay, so until there is like suppose the elements are given like 6 7 6 7 25 9 2 5 10. Okay, the elements are given like this. Okay, so now I will divide this into multiple sub arrays. So each is one sub array. Okay, each is one sub array. So until the division will be done in such a way that we'll get one sub array, one, like in one sub array we'll get only one element. Like that we will divide it. Okay, we will divide it. So how to divide it, sir? If you ask me, like, do you remember your do you remember do you remember your binary search? Yes, binary search. 0 1 2 3 4 5 6. So in the case of your binary search, what you will be doing? What you'll be doing? We will calculate the mid, right? We'll calculate the mid, right? Mid index will be calculating, right? Let me write down this here. We'll be calculating mid, right? Mid is equal to like lower index plus higher index by 2, which is nothing but 3. Okay, so this is your mid index now. So what will happen now? We will divide this mid index. Okay, we will divide this mid index side. So mid to minus 0 to mid minus 1 again. 6, 17, 25, 9. 25, 9. This mid also will be adding the same in the left hand. Okay, and then this again will divide. Okay, we'll divide it. So 2. This you can add it according to your logic. You can add it in the left subarray or in right subarray. Okay, so 2, 5, and 10. Okay, then again, screen is not visible. Is my screen not visible? Okay, Mangesh, you are having a problem, I guess. Please rejoin. Okay. So again, here what is 0, 1, 2, and 3, right? 0, 1, 2, and 3. And here 4, 5, 6. Again, we'll find out the mid element here. 0 plus 3 by 2, which is nothing but 4 by 2, which is nothing but like 3 by 2, which is nothing but 1.5 will come. We'll take it as 1. Okay, so this is your mid element. So we'll again do the sub arrays. Okay, we can add 6, 17 here, and then here 25 and 9. Okay, 25 and 9. Okay, so here also the mid element is 4 plus 6 by 2, which is nothing but 5. Right, so this will be the mid element. So we'll again do the sub array. 2 and then 5, and then here it will be only 10, right? And then again we will again here also what is it is 0 and 1, it is 2 and 3. Okay, 0 plus 1 by 2, which is nothing but 0.5. We will take it as 0 itself. Okay, so 6 will be coming here, 17 will be coming here. Okay, here 25, here 9, here 2, here 5. Okay, so like this it will happen until this point. We will do the division. Okay, we will do the division. Basically we'll divide it. Until this point we will divide it. Okay, so now how to sort, sir? If you ask me, how to sort, sir? If you ask me, direct this is one function call. Basically how it will be the function call. So basically if I take the merge function call, merge sort function call, so 0 comma like array comma, you will have your like your kick sort only recursive calls. How you will do 0 to n minus 1. Okay, and then now you'll be sorting here array like merge of, we will be sorting here merge of array comma, you will have your 0 to mid, right? 0 to mid. Here also array of mid plus 1, array of mid plus 1 to your n minus 1 or end minus 1 upper bound. Okay, then here also again you will do the same thing, array of merge comma 0, array of 0 comma mid. Here also the same merge, this is also a merge function, 0 comma like not 0, it is mid plus 1 to, it is mid plus 1 to like your upper bound, right? Mid plus 1 to mid. So basically mid plus 1 to, you can take it as mid itself. Okay, mid plus 1 to mid. So like this we will do the merging. For all this there is a function call. Okay, it's a function call. So now what will happen, this 2 I will be, now I need to conquer it, right? This 2 I need to conquer it. I will compare among this 6 and 17, which is least. So I will be putting it inside a array. So 6 and 17. So 6 is lesser than 17, right? So 6 I will be placing first and then 17. Okay, and then here also, and then this 6 and 17 are returned. Okay, this 6 and 17 are written, and then 25 and 9, which is lesser than, so first this will be coming 9 and then 25. Okay, 9 and then 25. Now you see 6 and 17 are merged and 9 and 25 are merged. Okay, this will be returned. This will be returned. This will be returned to at this point. Okay, at this point it will be returned, and we'll have these two things. Okay, now what you need to do, you will take another array now. You will take another array now. I will explain here itself how the merging will work. So we will take another array, like some B array will be taking. Okay, so this is your left array, this is your right sub array. Okay, so let me take a red pointer and I will explain this. You will understand great. Okay, so here I am putting the I value here. Okay, here I am putting the J value here. Are we clear until this point? I am explaining the algorithm. The merging algorithm is only different here. Okay, merging algorithm is only different here. I am explaining that, please understand. Okay, so here you see, here I am taking the I pointer, here I am taking the J pointer. Okay, now I will compare 6 with 9. Which is lesser? 6 with 9. I will compare. Which is lesser? 6, right? So I'll be placing that I value here. Okay, I'll be placing that I value here and I will increment the I pointer. So this will be your K pointer. Okay, this first one is nothing but your K pointer. Okay, K will be at initially 0. Okay, now K has come. So K will be moving to here. K will be moving to here. Now 17 is compared with 9. Which is lesser? J is lesser or I is lesser? J is lesser, right? So I'll be placing the J here. I'll be placing the J here and I will increment the K pointer as well as I will increment the J pointer. Now again 17 is compared with 25. Which is lesser? Which is lesser? I, right? So I will be placing the 17 here. Okay, then I will increment the K as well. I will increment the K, I as well. Now you see I has crossed. I has crossed the mid value. Okay, I has crossed that array, means I is done. Now only like now nothing will do. We'll place of the remaining elements from the right array. Since left array has already crossed the limit. So now we'll be just placing whatever the elements that were there in the right array. Only one element is there, that is 25. Are we clear? Yes. Okay, here also the same thing we'll do in the right subarray. In this also we'll do the same thing. So 2 and 5, 2 and 5, again the same thing. B array will be taking, this is your I, this is your J. So I 2 is lesser than 5, so 2 will be coming here and then 5 and then it is 10, right? It is 10. So this 10 will be compared again. Okay, so I and then J, I and J and your B array and then your B array. So now 2 is compared with 10. 2 is lesser. Then in this case, 2 will be coming here. This is your K pointer. This is your K pointer. So then I will be incremented. I will be incremented. K will be incremented. Okay. Then 5 is compared with 10. 5 will be coming here. I will be incremented. I has already crossed. Okay, then remaining elements what were there? That is 10. That will be placed here. Okay, so you have your 6, 9, 17 and 25, then 2, 5 and 10. Okay, now what you will be doing? What you will be doing? You will merge both of these sub arrays. You will merge both of these sub arrays into one array. Okay, you will take a array of n length. You will take a array of n length. Let's understand this. This is very important. Okay, so 1, 2, 3, 4 and then 5. If you are understanding the algorithm, then code is nothing, guys. Code will be nothing. If you understand the algorithm and if you are knowing what I am doing here, then code is nothing. You can easily understand. Okay. So I will be removing this everything. Okay. I will take some other pointer. Let me take blue. Okay, now this is your L. This is your right array. Okay, this is your right array, and then this is your some result array. Okay, you can take it as result array or B array or A array, something. Okay, so I'll be taking some other pointer. Let me take a green pointer. Now I is a tier, J is a tier. Okay, I is a tier, J is a tier, then K is a tier. Now I is compared with J. So if I if I if I so if I less than J, if array of I less than J, then what you need to do? You'll be placing at the in the B array, B of K is equal to B of I. Okay, you are left of I, basically you're left of I, and then you will increment the I pointer, right? You will increment the I pointer as well as K pointer. Okay, if I greater than J or I greater than J, then what I'll be doing? I can directly write the else condition, right? I can directly write else condition. Else B of K is equal to R of J. Okay, then J plus plus J plus plus K plus plus. Okay, J plus plus K plus plus. So these are your base conditions. Okay, then when I has exceeded the J, I has exceeded the J or J has exceeded the I, then I will be passing on the remaining elements. Okay, that I will be writing it up anyways. Okay, so I will also write out those things as well. If that is also there, then what you will be doing, you will place out the remaining elements. Okay, you'll place out the remaining elements. What were there? What were left out in the left array or right array? Okay, left array or right array, right? So if I has crossed mid, if I has crossed your mid, means it has the left array is completed. When the left array is completed, then you will be placing the remaining elements that were there in the right array directly, right? So what you need to do, you can take a while loop. And simply you can iterate over the right array itself. You can iterate over your right array itself while J less than or equal to upper bound. Okay, then what you will be doing, B of K. Okay, B of K is equal to you'll be placing the A of J. Okay, your right of J, basically your right of J. Okay, right of J, and then K plus plus, then J plus plus as well. In the same way you will be writing the J condition as well. J has crossed your lower bound, your upper bound, basically it has crossed the upper bound. Then what you'll be doing, you will write the same thing again. You will do the same thing again while means the right subarray has crossed, the right subarray is done. Then in that case, I less than or equal to mid. Okay, while I less than or equal to mid, B of K is equal to left of I, and then I plus plus K plus plus. So these are the leftover arrays, leftover right array or sub array when when it is done. Okay. So now coming back, let me go ahead with the black pointer itself and let me explain. Now K is at this position. Okay, K is at 0 position and I. So first what condition? I need to check if I is less than J. So 6 is less than J, 6 is less than 2. Yes or no? 6 is less than 2. Yes or no? Can I get a kick heads up in the chat box? 6 is less than 2 or greater than 2? 6 is greater than 2. So in this case, else condition will be executed. So what is else condition? What is else condition? B of K is equal to your R of J, means nothing but 2 will be coming here. 2 will be coming here. And then what will happen? J plus plus. J will be moving here. K plus plus. Okay, K plus plus means K will be moving here. Okay, and then again we are comparing I with J. Again while loop. Okay, while loop. So what I will be doing, I will compare, right? So 6 less than 2. 6 less than 2. Condition is true or false? 6 less than 5. Condition is true or false? Condition is false. So in this case, J will be coming here, right? So J will be coming here. J will be incremented and K will be incremented. Okay. So here now again 6 is compared with 10. 6 less than 10. Condition is true, false? Condition is true, right? So now I will be coming here, 6 will be coming here, and then K will be incremented. Okay. Then again 9 is compared with 10. 9 is compared with 10. 9 less than 10. 9 is less than 10 only. Then what I need to do, I will increment the I to here, and then 9 will be kept here and J will be staying here itself. And then 17 is compared with 10. 17 less than 10. Condition is true, false? 17 is less than or equal to 10. Condition is true, false? Condition is false. So in this case, 10 will be coming here. J will be exceeded. J will be exceeded. Okay. Then K will also be coming here. Okay. Now if you see, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. 7 elements are there. Huh? Okay. So now you see J has crossed the upper bound. So this is your upper bound, right? And this is your lower bound, right? So J has crossed the lower upper bound. So you'll also check this condition. If J greater than upper bound, J greater than upper bound, then what you need to do? While I less than or equal to mid, means I less than or equal to, this is your mid, right? This is your mid. So mid, this is your mid, then this is your mid plus 1. This is your mid plus 1, right? This position is mid plus 1 position. Then this is your mid position. So while I less than or equal to mid, it means you will keep out all the elements that were there in the B of K, in the result array. So 17 and then 25 will be placed. Okay. In the similar way, when I has crossed also, you'll place all the remaining elements without comparison in the last. Are we clear? Yes, no. Are we clear with the algorithm? Okay. So let me write the code. But how you will be running this loop? How you will be running this loop? Until when you will run this loop? This everything. Until when you will be running this loop? When only your when only your I is lesser than or equal to mid, or J is lesser than or equal to upper bound. Okay, when I is lesser than or equal to mid and J is lesser than or equal to upper bound, you can run this loop iteratively until this point. Until this point. Okay, until this point. Once it has crossed out of the loop, you will be running this both conditions for checking. Okay, both conditions for check. Okay, this will be the thing. Okay, this will be the thing. So can you code this up? The merging logic is already there. I need your own code, your own logic in just dividing it. That's it. In just dividing that logic, I need that. Like how this one, like already the merging logic I have written in the case of like how I written in the case of your partition in your kicksort. I have written the partition. I have shown you the logic, right? So this instead of partition, you will have the merge logic I have shown to you here. Okay, the merge logic already I have written here. Okay, just I need from you the solution is this one. Okay, instead of kick, you need to divide it. Division of the array by kick by calling the recursively. So can you do that? Can you do that? Can you try this out code by seeing this logic? Okay, can you try out this code? Can you try out this code? For 5 minutes, I will give the time. Please implement the code by your own. If you're not getting still, then I will implement in my editor. Okay, can I start writing or you're trying it still? Okay, I'll be writing the code. So Kajal, in YouTube, you will have the recording, okay, on the channel. XLR channel, you will have the recording. You can watch from there. Let me create a new class. Array equal to. Let me copy it from here. Okay, but here we'll be doing the merge sort logic. Okay, merge. Okay, merge sort logic from 0 to array dot length minus 1, correct. Okay, then I will move here, and first I will be writing the merge logic. Okay, static. Okay, you can take a static void merge. Okay, static void merge. Then you can get this done. Okay, then here you need what? You need an array as the input, and you need a start index. Okay, you need a end index, right? So basically lower bound and upper bound. You need lower bound, then mid value as well. Okay, mid value, what is the mid value also you want, and then you want the upper bound value as well. Okay, so before that, what I'll be doing, I will write the merge sort logic only. So create method. Where it has written. Okay, static void merge sort. And then what I need to do inside this, I need to find out the middle element first. Right, for division, I should be finding the middle element first. So let me take it as lower bound and then upper bound. Okay, intermediate is equal to lower bound plus upper bound. Okay, by 2. Okay, by 2. Okay, then I will be dividing this array, right? So for that I need to call it recursively. So merge sort of array from I will be using the array, and then until where I should merge sort. So basically lower bound to mid, right? And then merge sort of, and we merging your mid plus 1 to upper bound to the end of the array basically. Okay, then I will perform the merging. Once the division is done, I will perform the merging array comma. You will have your lower bound to mid I need to merge, and then from mid to upper bound also I need to merge. So I'll be calling the merge function. Okay, I'll be calling the merge function here. Okay, now I will start the merging here. So what I should do for merging? First, I should be checking if like I should do this merge sort only if there are two elements are there. Okay, only if there are at least two elements. If that there are not two elements, like if the two elements are not there, then if lower bound is if upper bound so basically if lower bound double equal to upper bound, then what I need to do, I just return it. Okay, means there is only one element, we cannot do anything. So in that case, what I'll be doing, I will just return it. Okay, I will just return that when low is like basically when low is like double equal to upper bound, then definitely there is only one element there, so no need of merging there. I will just return it. Okay. Then what I'll be doing, I will come here and then I will, so what I should do, I'll be starting the while loop, while, so while lower bound less than or equal to, so let's take I pointer only. We'll take the I and j pointer. That will be easy, right? We'll end that way. So int j is equal to upper bound. Okay, int j is equal to upper bound. If lower bound, if I less than or equal to mid. Okay, if I less than or equal to mid and j less j less than or equal to upper bound, then only you run the loop. You run the loop. So if array of I, if array of I lesser than or equal to, if array of I lesser than or equal to array of j, then what I need to do, I will be placing, I will be taking another array here, a result array. Okay, I will be taking a result array. Int result array is equal to new int of n, new int of upper bound. Okay, new int of upper bound. So I'll be taking another variable here, int k is equal to 0. Okay, so b of like result of k, okay, result of k is equal to, result of k is equal to, left also I should see, right? Left also I should divide it here. Left array and right array, you are getting it from here, but you should divide it as well, right? You should also divide the left and right arrays there, right? So for that reason, first I should check left and right also. Like I and lower bound were correct. I and lower bound were correct, but you should be check. You should be dividing that as well, right? If it is left or right, okay, that's fine. Array of I, okay, array of I, and then k plus, and then j plus plus, okay. No, no, I plus plus, then k plus plus. Okay, then the same thing you'll be doing again. If else, what you'll be doing, if else, what you'll be doing, you will do the same thing here also. The result of k is equal to array of j and then j plus plus, j plus plus, k plus plus. Okay, when this has crossed, means either I has in the left array that is already done, or right array is already done. Then in that case, what you should be doing, while, you should write your conditions here. Okay, while, like I should check those conditions as well. If I greater than mid, means I is already done, means in the right subarray the elements are there, you should be directly placing those, right? So while j lesser than or equal to upper bound, then what you will be doing, you will just place out the elements in the result array. Result of k is equal to array of j, array of j, k plus plus, j plus plus, k plus plus. Okay, you will do the same thing for, you will do the same thing for j as well. While j greater than upper bound, while j greater than upper bound, while j, then what you need to do, while I less than or equal to mid, then rest of k is equal to array of I plus plus, k plus plus. Okay, so this is how we will be doing the, we'll be doing the merging. Okay, this is how we'll be doing the merging. This result array we have taken here. Okay, the result array we have taken here. Okay, what you can do, you can directly return the result array itself. Uh, you can directly return that result array. Okay, you can directly return that result array, and what you can do, you can change this return type to array, so that here we'll be catching it. Here we'll be catching the result array. Okay, int array is equal to result, and then I will print it off from here itself. Okay, so int d result, then sys out of d. Okay, and then if you can see, I will remove this property. Okay, are we fine with this algorithm? So what we are doing, we'll check. So main method will be called first, then array will be initialized, and then we are calling the merge sort function from 0 to array dot length minus 1. And then what we are doing, if there is only one element, when lower bound is double equal to your upper bound, when there is only one element, what we are doing, we're just returning it. If it is not, we are carrying out the mid element, and then we are dividing it, merging, like we are dividing it by calling it multiple times. LB to mid and mid plus 1 to upper bound, and then we are merging it up. While we are merging it up, we are checking all these conditions. Okay, we are checking all these conditions. We are taking a result array, and then we are checking all these things. I less than or equal to mid, when j less than or equal to mid only, you should check this condition and you will be merging. If the left array is already done, then if the left array is already done, then what you will be doing, you will put out all the elements that are there remaining in the right from the right array in the result array. This is only we are doing from here also. Okay, let me run this. Okay, exception in thread, array index, out of bounds, exception. Why we are getting out of bounds exception? For length 1, index out of bounds for length 1, where we are getting it? Merge of 30th line, 30th line, where is the 30th line? Yes. S of k is equal to res of k plus plus, correct? This is that should be new int of upper bound itself, right? Upper bound, okay, upper bound plus 1, because from here we are passing just length minus 1, right? Otherwise we can directly pass array dot length itself. Again, that's fine. Upper bound plus 1 should be the array. Otherwise, we can directly pass here array dot length itself. Okay, let me run this now again. Okay, all I got zeros. Why is it? Why it is not filling it? Why it is not filling it? Will be k is equal to 0. Okay, array of k, then I plus plus k plus plus, result of array. Okay, what I will be doing today, I will be giving this code to you only. Like the assignment for today is, you have understood the merge sort algorithm. Okay, you have understood the merge sort algorithm, and but the thing is here, when I am printing it, my input array is like this: 8, 6, 15, 19, 7, and 5. But my output array I am getting it as like this. Okay, like this, some zeros I am getting. Okay, some zeros I am getting. What is the issue in this code? Just find it out. Just debug, dry run, and then find it out. Got it, Ayush, Anurag, Sirisha, Kajal? Yes, and everyone. So I'll be sharing this code with you in the notes as well as in the chat box. Okay, just copy this. Just copy this code, put it in your editor, dry run the code. Okay, dry run in the sense with your mind. You dry run it each and every line by taking this input only. In your book, take a notebook, and you start it from main method. You write out this array in your notebook, and then you call the merge sort. and the function will be called here. Then 0 to array dot length minus 1. You take it as lower bound as 0, upper bound as length minus 1. Okay, and then you will check this condition. Okay, and then mid is equal to lower bound plus upper bound 2, and then draw one stack diagram. Okay, I've explained to fact, right? To factorial I've explained. Draw that stack diagram. Okay, draw the stack diagram, and draw the stack diagram, and like how I explained to factorial, like that you draw all these merges or things as well. Okay, in that you fill up that stack, and then while you are returning, what is happening? While you are returning, what is happening? Just check somewhere the issue is there. Okay, somewhere you say the issue is there. You just
It's
go
9
to the
o'clock.
merge and check that where the issue is. Tomorrow I want in which line the error has occurred. While I start the session itself, I want the answers in the chat box on which line the error has occurred. Okay, please don't put it on the chat GPT. Okay, please don't put it on the chat GPT. Don't compare with the online code. Just dry run the code by yourself with honesty and let me know, solve that error and let me know on which line the error has occurred. Tomorrow I will solve this. Are we clear, everyone? I'm sharing this with you. Okay, please dry run this code, copy up right now itself. Whoever is there until now, they were dedicated students only, I feel. So please copy this code from the chat box. It is already shared. Okay, and then put it on your editor, save it up somewhere in your editor, and let me know once after the like tomorrow in the start of the session. Please let me know where the error has occurred. Okay, are we clear until this point? Yes, everyone. Yes, I have already shared the code in the everyone section. Please take it out from their mod. Okay, I hope we are clear until this point. I will wind up the session here. Have a great day, guys, and good night. Thank you so much.
Yeah, thank you, sir. We'll meet again by tomorrow at 7 p.m. Thank you so much. Good night. Yeah, so dear students, kindly mark your attendance. We'll wind up for the day. Thank you all for joining. Good night.